Auroras, also known as the northern and southern lights, are among the most spectacular natural phenomena visible on Earth. These luminous displays paint the sky with vibrant shades of green, red, purple, and blue, creating ethereal curtains, arcs, and spirals that dance across the polar night. But what exactly causes auroras? And why might they become more visible, even in places like the United States, during the years 2024 and 2025? The answer lies in the intricate dance between our planet and the sun, a relationship governed by powerful magnetic fields, streams of charged particles, and the rhythmic ebb and flow of solar activity. To understand auroras, we first need to journey 150 million kilometers away to the heart of our solar system. The sun, a colossal sphere of plasma, is far from a static ball of fire. Its surface constantly boils and churns with immense energy. Sometimes this energy erupts in the form of solar flares and coronal mass ejections, huge bursts of charged particles, primarily electrons and protons, that are hurled into space. This outflow of particles, known as the solar wind, streams outward in all directions, occasionally intersecting with the magnetic field of our own planet. Earth is protected by its magnetosphere, an invisible shield generated by the motion of molten iron deep within its core. The magnetosphere deflects most of the solar wind, but at the poles, the magnetic field lines curve down into the atmosphere, forming a kind of funnel. When a particularly strong gust of solar wind, especially from a coronal mass ejection, slams into the magnetosphere, it energizes the particles trapped within it. These energized electrons and protons spiral along the magnetic field lines toward the polar regions, where they collide with atoms and molecules in Earth's upper atmosphere. The collisions are key to the auroral display. When charged solar particles strike oxygen and nitrogen atoms high above the ground, they transfer energy, exciting these atoms. As the atoms return to their normal state, they release photons, tiny packets of light. The color of the aurora depends on which gas is involved and at what altitude the collision occurs. Green, the most common color, comes from oxygen about 100 kilometers above the ground. Red auroras, rarer and often seen at higher altitudes, result from oxygen as well, but at lower pressure. Nitrogen produces purple, pink, and blue hues. Auroras typically shine in two broad bands encircling the magnetic poles, the auroral ovals. These ovals shift and expand in response to solar activity. During periods of intense solar storms, the ovals stretch towards the equator, bringing auroras to latitudes much farther from the poles than usual. This is why, on rare occasions, people in places like the northern United States, Central Europe, or even further south have witnessed these celestial light shows. But why should we expect more frequent and widespread auroras in the years 2024 and 2025? The answer lies in the sun's own rhythms, governed by an approximately 11-year solar cycle. The solar cycle is a pattern of increasing and decreasing solar activity, most visibly tracked by the number of sunspots, dark, cooler regions on the sun's surface associated with intense magnetic fields. At the peak of this cycle, known as solar maximum, the sun is peppered with sunspots, and solar storms become more frequent and powerful. During solar minimum, sunspot numbers dwindle, and the sun's overall activity calms. As of 2024, the sun is ramping up toward the peak of solar cycle 25, which is expected to reach its maximum between 2024 and 2025. Scientists have observed the number of sunspots rising, and with them, the frequency of solar flares and coronal mass ejections. This increase in solar activity means more charged particles are being hurled toward Earth, intensifying the solar wind and triggering more dramatic displays of auroras. In the United States, this translates to more opportunities for people to see the northern lights, especially in states that aren't usually within reach of the auroral oval. During major geomagnetic storms, the auroral oval expands, and the lights can be visible as far south as the central or even southern United States. Recent years have already seen some spectacular displays, with residents in places like New York, Ohio, and even as far south as Arizona catching glimpses of shimmering green and red skies. The intensity and extent of the aurora are measured using the KP index, which ranges from 0 to 9. A KP index of 5 or higher indicates a geomagnetic storm strong enough to push auroras far from the poles. During the solar maximum, such storms become more common, making aurora sightings possible over much larger areas. But the story of auroras doesn't end with the science. It is also a story woven into the fabric of human culture and history. For millennia, people living in high-latitude regions have looked up in awe at the flickering lights. The Inuit believed the lights were spirits playing in the sky. In Norse mythology, auroras were seen as the glimmering armor of Valkyries riding to battle. In medieval Europe, unusual displays of auroras were sometimes interpreted as omens, heralding significant events or disasters. Today, auroras are a source of wonder and inspiration, attracting travelers and photographers from around the world. Modern technology, including smartphones and digital cameras, has made capturing these elusive lights easier than ever before. Social media channels light up with images and videos each time a powerful geomagnetic storm sweeps across the planet. However, the increased solar activity that brings us these breathtaking spectacles also has a shadow side. Powerful solar storms can disrupt satellite communications, interfere with GPS signals, and, in rare cases, even knock out power grids. In 1989, a massive geomagnetic storm caused by a coronal mass ejection plunged the Canadian province of Quebec into darkness for several hours. Airlines, spacecraft operators, and power companies closely monitor solar weather, taking precautions during periods of heightened solar activity. Despite these challenges, the scientific value of solar maximum periods is immense. Researchers use the influx of particles and energy to study Earth's magnetic field, the behavior of the upper atmosphere, and the complex interactions between the Sun and our planet. Satellites equipped with sensitive instruments monitor the Sun's activity, providing early warnings for potential impacts on technology and infrastructure. For those hoping to see the aurora in the United States during the 2024-2025 solar maximum, there are a few tips to maximize your chances. First, seek out dark skies, far from city lights, as light pollution can wash out the delicate glow of the aurora. Auroras are most commonly visible between 10 p.m. and 2 a.m., though strong storms can make them visible earlier in the evening or later at night. Check aurora forecasts and space weather websites, which track the KP index and issue alerts when geomagnetic storms are likely. And most importantly, be patient and keep your eyes on the northern horizon. Sometimes the show builds slowly before bursting into vibrant color. Photographing the aurora requires a camera capable of long exposures, a tripod, and a bit of trial and error. Even when the aurora appears faint to the naked eye, cameras can often pick up more subtle colors and patterns. The 2024 to 2025 solar maximum offers a unique window of opportunity. Not only are auroras likely to be more frequent and intense, but they may also reach lower latitudes, allowing millions more people to experience their magic for the first time. As the sun's activity peaks, the interplay of solar wind, Earth's magnetic field, and our atmosphere will combine to produce some of the most dramatic auroral displays in years. Beyond the beauty and spectacle, auroras are a reminder of our planet's dynamic relationship with the cosmos. They are visible evidence of the powerful forces at work in our solar system. Forces that, while invisible and distant, can reach across space to touch our lives in profound ways. Each aurora is a fleeting connection between Earth and Sun, a dance of light that links us to the vast energies that shape our world. The coming years will be an exciting time for scientists, sky watchers, and anyone who treasures the majesty of the night sky. The return of the solar maximum is a rare and precious event, a chance to witness one of nature's most extraordinary performances. Whether you see them from the frozen tundra of Alaska, the forests of Minnesota, or the rolling hills of Kentucky, The northern lights are a gift from the sun, a silent, dazzling reminder of the mysteries that surround us. As you prepare for the possibility of witnessing an aurora, remember that the experience is as much about patience and wonder as it is about science. Sometimes the sky remains quiet. Other times it erupts in color and motion, surpassing all expectations. Each display is unique, shaped by the complex and unpredictable dance of solar and terrestrial forces. So, as the sun approaches the peak of its 11-year cycle, and as forecasters predict more intense and widespread auroras, take the opportunity to look up, to marvel, and to connect with the natural world in a profound and unforgettable way. The northern lights are not just a scientific phenomenon, they are a universal symbol of beauty, mystery, and our enduring fascination with the sky. And in the years ahead, they may shine brighter and farther than they have in a generation. Let this solar maximum be a time to rekindle our sense of curiosity, to celebrate the wonders of our universe, and to remember that even in the darkest nights, there is always the possibility of light. In summary, auroras are the result of charged solar particles colliding with Earth's atmosphere, producing shimmering lights near the poles. Their visibility depends on solar activity, which follows an 11-year cycle. As we enter the peak of solar cycle 25 in 2024-2025, increased solar storms will send more charged particles toward Earth, expanding the auroral ovals and making auroras visible at lower latitudes, including across much of the United States. This rare opportunity invites more people than usual to witness the magic of the northern lights, a reminder of our planet's place in the cosmic dance of energy and light.